Stephen Hawking was definitely one of the greatest minds in modern science, and he dedicated his life to answering the biggest questions of the universe. Through his outstanding research, he went over the nature of time, space, and existence themselves, giving humanity a look into the origins and fate of the cosmos. In his writing, mainly A Brief History of Time and the Theory of Everything, Hawking tells what can best be described as the story of everything. Hawking begins his journey with the Big Bang, the moment, around 13.8 billion years ago, when the universe burst forth into existence. According to Hawking, it was not an explosion of matter, but the very birth of time and space themselves. Before this, there could not have been any before, as we understand the concept of time. The universe, initially a singularity, an infinitely dense point, expanded fast and furious, generating the cosmos in which we live today. It is also important to note that Hawking was key in bringing general relativity and quantum mechanics, two incompatible ideas of modern physics, under the same umbrella. General relativity explains large, massive objects in terms of stars and galaxies, but quantum mechanics addresses tiny particles constituting the universe. This is where the genius of Hawking lay, because he applied principles of quantum theory to black holes to produce one of the most famous theories he discovered, called Hawking radiation. Black holes, which were considered unescapable voids, were demonstrated by Hawking to emit tiny amounts of radiation over time. This changed the conventional way of thinking, as it was realized that black holes could eventually shrink and disappear. Hawking radiation bridged the gap between quantum mechanics and relativity, but also raised fundamental questions about the nature of information in the universe. Central to Hawking's study of everything was time. He famously proposed that time itself had a beginning, like the surface of a sphere. Just as a sphere has no edges, the universe has no before the Big Bang. He also introduced the concept of imaginary time, a mathematical construct that could help resolve some of the paradoxes in theoretical physics. Hawking also went beyond the origins of the universe and delved into its eventual fate. He looked at the Big Crunch, the end of the cosmic cycle, where the universe might reverse the expansion and collapse back into a singularity, and the Big Freeze, which expects the universe to expand forever, growing more and more desolate as the last stars burn themselves out. His work drew attention to the teeny-weeny balance of cosmic forces and the way they determine our destiny. Beyond the technical theories, Hawking had an extraordinary ability to make complex ideas accessible to the public. Concepts like black holes, parallel universes, and curvature of space-time came alive for millions through his books. He often put these ideas into the context of the ultimate question: why does the universe exist, and why do we exist within it? Hawking used the last decades of his life to collaborate with others to find even bolder questions to address. Among them was the multiverse theory, which suggests that there are many different parallel universes. He claimed that our universe is just one of many universes, each set of physical laws and conditions different from the others. It is purely speculative, but this opens up our understanding of reality in ways that make it plausible that our existence could be only one among infinite possibilities. Hawking also warned about the future of humanity. He believed that exploring the cosmos was essential for our survival. He advocated for space colonization, suggesting that life on Earth faced significant risks from events like nuclear war, climate change, or asteroid impacts. He envisioned a future where humans could inhabit other planets, ensuring the continuity of our species. Though Hawking passed away in 2018, his work continues to inspire scientists and thinkers worldwide. Advances in cosmology, such as the recent observations from the James Webb Space Telescope, have begun to provide deeper insights into the early universe, supporting some of Hawking's theories. Meanwhile, ongoing research into black holes and quantum physics builds on his groundbreaking ideas. The story of everything that Stephen Hawking wanted to tell is about not only the understanding of the universe, but also finding one's place within it. His work reminds us of the power of human curiosity and of profound questions driving us to the unknown. Hawking's legacy lives on in the continued quest for a theory of everything, a unified framework that explains all physical phenomena in the universe. Whether or not this ultimate goal is achieved, Hawking's contributions have forever changed how we see the cosmos and ourselves within the grand tapestry of existence.